Now let's go to the United States, where millions of people in Florida are struggling with...
A lot of people used to think that because a tsunami is essentially a huge flood that comes in, you cannot have fires.
Beneath the sun-drenched waters of Florida's coastline, marine researchers recently stumbled upon a discovery so profound that it prompted the U.S. Geological Survey (USGS) to issue a warning. What initially began as a routine seabed mapping project has since revealed the presence of a vast, complex, and potentially volatile geological structure lurking just beneath the surface of the seafloor. Hidden beneath the Gulf Stream's currents and Florida's iconic reefs lies a formation that is raising alarms not just for geologists, but for environmental scientists, engineers, and coastal planners alike. Before we start, smash the like and subscribe buttons for more updates. The discovery centers around a massive, semi-active fault line stretching far longer than previously documented, running deep beneath the Florida platform, a largely carbonate geological formation that underpins much of the Florida peninsula. At first glance, it seemed like just another sediment anomaly, but as sonar imaging, seismic surveys, and sediment core analyses came together, a startling picture began to emerge. The fault isn't merely dormant or residual from ancient tectonic activity. It shows signs of recent movement, indicating that the region may be far more seismically dynamic than scientists had long assumed. Historically, Florida has been considered one of the least earthquake-prone states in the continental United States. Its position away from the major plate boundaries led to the assumption that the risk of seismic activity was negligible. This new data challenges that assumption. Researchers have uncovered layers of disturbed sediment patterns, fracture lines in bedrock, and subtle shifts in the geological strata that all point to episodic releases of energy, the hallmarks of tectonic motion. This movement, while not on the scale of the California San Andreas Fault, could still have far-reaching consequences, especially for Florida's delicate coastal ecosystems and densely populated shorelines. The USGS, after reviewing the accumulated data, deemed it necessary to issue a formal warning. This isn't due to immediate danger, such as an impending earthquake, but rather to signal a fundamental shift in understanding the region's geological behavior. The fault line appears to interact with deep subterranean aquifers, which are not only essential to Florida's freshwater supply, but are also highly sensitive to pressure changes and tectonic stress. If disturbed significantly, the aquifers could become pathways for saltwater intrusion, contaminating groundwater and posing a threat to millions of residents who depend on them. The implications ripple far beyond hydrology. Florida's coastal infrastructure, including high-rise condominiums, bridges, seawalls, and even underground pipelines, was constructed with the assumption of geological stability. An active fault line throws those assumptions into question. Even low-magnitude seismic activity, if persistent or strategically located, can exacerbate subsidence, undermine foundations, and compromise the integrity of structures over time. With sea levels already rising and storm surges becoming more powerful, the state's physical vulnerability is now layered with an unsettling tectonic uncertainty. Equally concerning is the fault's proximity to Florida's extensive karst system. Karst terrain, characterized by soluble limestone bedrock, is highly susceptible to sinkholes, which have long plagued regions like central Florida. These underground voids can suddenly collapse, swallowing buildings, roads, and vehicles. A shifting fault could act as a trigger for widespread sinkhole development, setting off a cascade of subsurface collapses across an already at-risk region. If such events coincide with rainfall or rising groundwater levels, the consequences could be catastrophic. Marine researchers also uncovered signs that the fault line might be interacting with undersea methane hydrate deposits. Methane hydrates are ice-like crystals found beneath the ocean floor, where methane is trapped within a lattice of water molecules. While stable under specific pressure and temperature conditions, these deposits can destabilize with even minor geological disturbances. The presence of methane hydrates in close proximity to an active fault raises the specter of gas releases, which can contribute to underwater landslides and, in extreme cases, release massive amounts of greenhouse gases into the atmosphere. This newly uncovered dynamic system also sheds light on mysterious acoustic anomalies that marine biologists have recorded over the years. Unexplained underwater rumblings, once attributed to distant tectonic echo or large marine mammals, may now have a local origin: subtle seismic activity along the newly mapped fault. These vibrations could have ecological consequences, particularly for sensitive marine species that rely on sound for navigation, mating, and communication. Coral reefs, already stressed by rising temperatures and ocean acidification, might be further destabilized by even mild seafloor shifts, threatening the biodiversity they support. Adding another layer to this growing concern is the potential impact on Florida's already complex hurricane season. While tectonic activity and weather systems operate on different principles, there is some evidence to suggest that disturbances in the seafloor can influence water column stability, potentially affecting ocean currents and local thermal gradients. These factors, in turn, play roles in storm formation and intensity. Though speculative, it's a possibility that researchers are now exploring with renewed urgency. From a broader scientific perspective, this discovery represents a paradigm shift in how geologists interpret the southeastern United States subterranean architecture. The Florida platform, once considered a passive, tectonically quiet zone, may be part of a larger system of microplate movements previously overlooked due to limited instrumentation and assumptions of stability. With the advancement of deep-sea imaging and improved data modeling, previously unseen features are coming to light, revealing a more active and complex crustal story than previously imagined. Engineers are already studying how this development should influence future building codes in Florida. Existing infrastructure, especially that near the coast or built on reclaimed land, will need reassessment. New regulations might need to factor in minor but chronic ground shifts, requiring buildings to be designed with greater flexibility and redundancy. Utilities such as gas lines, water systems, and electric grids may also need to incorporate adaptive measures to handle unexpected stress or movement. In the energy sector, there are further ramifications. Offshore drilling operations, though limited in Florida due to environmental regulations, do exist in nearby waters and may be impacted by this fault line. Even if operations are suspended, the existing boreholes and wellheads could be at risk if the seafloor shifts, potentially leading to underwater leaks or destabilization of capping structures. Environmental risk assessments will now need to consider this newly discovered fault as a factor in long-term planning. The tourism industry, a vital pillar of Florida's economy, could also face indirect impacts. News of seismic potential, even without an immediate threat, may alter public perception of safety, particularly among international visitors or those considering investing in coastal property. Real estate markets, which have long boomed along the pristine coastlines, might need to reckon with updated geological risk profiles. Insurance companies, in turn, may adjust their policies and premiums, taking into account the new data emerging from this discovery. Educational institutions across Florida are preparing to integrate this information into their research and curriculum. Geology departments are launching new studies into the state's subterranean behavior, while marine sciences are pivoting to monitor ecological responses to the shifting seabed. Students and academics alike are mobilizing to collect data, run simulations, and contribute to a rapidly expanding field of inquiry that could redefine the geological identity of the entire southeastern United States. From a policy perspective, the USGS warning acts as a critical prompt. While it doesn't indicate immediate disaster, it calls for proactive legislation, updated emergency response protocols, and investment in long-term resilience. Coordination between federal, state, and local agencies will be essential to map out response strategies, update zoning laws, and enhance public education about the nature and scope of the risk. At the global level, Florida's unexpected tectonic reveal is joining a growing list of regions where quiet plates are showing signs of reawakening. Geologists are increasingly considering that continental interiors may not be as inert as once believed. From parts of the Midwest to the Southeast, subtle fault systems are being reevaluated with more sensitive equipment, changing the global map of seismic hazard zones. For the scientists who first detected the anomaly, the discovery is both exhilarating and sobering. It opens doors to decades of research while highlighting the fragility of assumptions that have guided development in the region for more than a century. The seabed is no longer viewed as a static foundation, but as a living, shifting puzzle that holds keys to understanding the planet's deeper mechanics. And Florida, once considered geologically tame, is now on the frontier of that understanding. Subsequent explorations will focus on refining models of the fault's behavior, tracking its extent, and determining its interactions with both natural and man-made systems. Underwater drones, satellite gravimetry, and deep core drilling will all play roles in mapping this hidden force. Marine biology, environmental science, civil engineering, and climatology will need to converge, forming a new multidisciplinary effort to address the emerging challenges. This moment marks a scientific inflection point. What was once unseen beneath the waves now demands attention from every sector. From governance and infrastructure to science and citizen awareness. The waters off Florida's coast have always held secrets, but none so transformative and urgent as this. The discovery redefines risk, reshapes perception, and sets the stage for a new era of understanding about what lies beneath the surface, not just in Florida, but across all the hidden boundaries of our shifting planet. The enormity of the Florida fault discovery continues to unfold as scientists dig deeper into the structure's origin, behavior, and broader implications. What began as a startling geological revelation has now expanded into a full-scale scientific investigation that is already influencing how experts model tectonic motion in subtropical coastal zones. As studies intensify, attention has turned toward the fault's age and the role it may have played in shaping Florida's unique geological landscape over millions of years. Initial isotopic dating of sediment layers disrupted by the fault suggests that its formation could trace back as far as the late Cretaceous period, a time when dinosaurs roamed, and the continents were still drifting into their current positions. This fault line may not be a newcomer to the region, but rather a sleeping titan that has awakened intermittently through geological history. Its long dormancy might explain why it evaded detection for so long. Embedded beneath thick sediment and concealed beneath calm waters, the fault's subtle reactivations have gone unnoticed, masked by the region's relatively quiet surface behavior. Further analysis points to the possibility that this fault is part of a broader, interconnected system of intraplate stress zones. Unlike faults formed at plate boundaries, intraplate faults develop and behave differently. They're influenced by long-distance stress transfers across rigid crustal blocks. In the case of Florida, the movement of the North American plate, though distant from any major subduction zones, still exerts internal pressure. These accumulated stresses, though often diffused across wide areas, may be periodically discharged through weaker zones like this newly discovered fault. More unexpectedly, researchers have detected slight magnetic anomalies near the fault, suggesting the presence of ferromagnetic minerals aligned by past geophysical activity. This has sparked interest among geophysicists and mineralogists, who are eager to study whether the fault also acts as a conduit for subterranean mineral migration. If confirmed, it could have implications not only for understanding Earth processes, but also for potential resource mapping. The discovery is reshaping how we understand Florida's stratigraphy. It was long believed that the sedimentary layering beneath the state formed in relatively stable conditions, horizontal bedding undisturbed by large-scale tectonic forces. However, new subsurface scans show tilting and folding in several regions, some more recent than previously expected. These folds are likely the result of episodic fault activity and are causing a reassessment of sedimentary timelines across the entire southeastern coastal plain. This affects everything from petroleum basin models to freshwater aquifer flow projections. The scope of concern isn't limited to Florida's landmass. The surrounding seabed, especially along the continental shelf, exhibits signs of fault-related deformation. Bathymetric surveys reveal trench-like depressions and linear escarpments that appear to correspond with the fault's orientation. These features, though subtle, indicate potential zones of past slippage and may serve as weak points where future seabed instability could occur. Underwater landslides in such areas pose serious risks, particularly for underwater infrastructure like telecommunication cables and research stations. In parallel, climatologists are growing increasingly interested in the interplay between this geological shift and the broader climate system. A more dynamic subsurface environment may influence coastal upwelling patterns, where nutrient-rich cold waters rise to the surface. Even a modest adjustment in the seabed topography or current path could alter these systems, impacting local marine food chains and regional fishing industries that depend on them. A shift in upwelling dynamics might affect the abundance and location of commercially important species like snapper, grouper, and mackerel. Coastal morphology could also be affected. If parts of the seabed are gradually uplifting or subsiding due to fault creep, a slow, continuous movement along the fault, this could lead to local variations in sea level that go beyond global sea level rise. Some coastlines may begin to experience anomalous erosion or accretion patterns that diverge from predictions made under traditional sea level models. In regions where beach tourism or coastal development is key, such changes could carry substantial economic consequences. Marine archaeologists have taken a particular interest in how these shifts might disturb submerged historical sites. Florida's coast is dotted with the remnants of shipwrecks, ancient trade routes, and even prehistoric human settlements from eras when sea levels were lower. If seabed motion dislodges sediment layers that have preserved these sites, it could either expose them for discovery or, more likely, destroy them before proper study can be done. New guidelines are being proposed for sonar scanning and archaeological diving in areas now considered geologically unstable. The aerospace and satellite industries are also stepping in. With the fault discovery increasing the need for high-resolution monitoring, companies specializing in Earth observation satellites are redirecting their sensors to the region. Synthetic aperture radar (SR) is being employed to detect minute changes in ground elevation across Florida's surface, down to millimeter-level shifts. These measurements will allow for the creation of precise deformation maps, which can identify areas at risk long before structural damage occurs. Beyond physical risk, the fault raises philosophical and cultural questions about Florida's future. For decades, the state has marketed itself as a paradise: stable, warm, inviting. Its identity has rested partly on the idea of permanence. The notion that the ground itself may be shifting calls that into question. Artists, writers, and filmmakers are beginning to explore this theme in their work, highlighting how nature continues to rewrite the rules of existence, even in places we believe we know intimately. Meanwhile, oceanographic studies are being ramped up to examine whether the fault may interact with deeper oceanic currents, particularly those that feed into the Gulf Stream. The Gulf Stream is a powerful regulator of Atlantic Ocean temperature and a driver of weather across the East Coast and Europe. Even a slight disruption to its flow could have profound climatological effects. While the current evidence doesn't indicate that the Florida fault directly influences this system, its alignment and depth make it a subject of interest for long-term ocean monitoring. In the legal arena, questions are beginning to arise about liability and disclosure. Real estate developers and sellers may soon be required to inform buyers if a property is located near a newly classified seismic risk zone. Insurance firms are reassessing coverage models, while local governments may face pressure to conduct rapid geotechnical surveys before approving new construction projects. Legal experts anticipate a surge in policy revisions and possibly litigation, especially if any property damage arises in areas now flagged for ground instability. Academia, meanwhile, is undergoing a pivot in training and education related to southeastern geology. University programs in Florida and neighboring states are revising their course frameworks to include tectonic theory as it pertains to intraplate fault systems. Geology students who might have focused on resource extraction or groundwater management are now being equipped with tools to analyze dynamic crustal movement. This wave of re-education is aimed at preparing a new generation of scientists to confront the complexities unveiled by the discovery. At the federal level, agencies are collaborating to ensure that data collected from the Florida fault is shared across platforms. The Department of Homeland Security, NOAA, NASA, and FEMA have all signaled interest in contributing to ongoing research, ensuring that the implications for national infrastructure, disaster preparedness, and climate modeling are integrated into national resilience planning. A multi-agency task force may emerge from this, creating a coordinated strategy to monitor, respond to, and educate about fault-related activity in low seismic zones. The financial world is also taking note. Risk analysts in the insurance and reinsurance industries are incorporating this new data into probabilistic models. Florida's already complex risk portfolio, which includes hurricanes, flooding, and sea level rise, now has an added variable. Large financial institutions involved in mortgage lending and municipal bonds may begin adjusting their exposure in coastal markets, introducing higher thresholds for investment or requiring geological assessments before underwriting long-term projects. As the investigations continue, the integration of AI-driven data analysis tools has become invaluable. Machine learning models are being trained to predict fault behavior based on seismic noise, soil composition, hydrological changes, and satellite data. These tools can process vast data sets that would overwhelm human analysts and are already offering early insights into micro-patterns that could forecast future slippage zones or periods of increased subterranean pressure. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on USGS warning, and what do you expect happens next? We want to hear from you. Thank you for watching, and see you next time.